In this video, we are going to explain about a project titled Object Detection in Different Weather Conditions using yolov5. Object detection is a critical task with numerous applications, but its effectiveness can be hampered in adverse weather conditions. In this project, we embark on transformative journey to overcome this challenge. Leveraging the power of yolov5, a state-of-art object detection model, we aim to build a robust system that can accurately detect the objects in real time under the various weather scenarios like rain, fog, and snow. By training the model on the diverse weather data set and the fine-tuning it for specific conditions, we seek to enhance its performance and reliability. The objective of this project is to develop an efficient and reliable object detection system using yolov5 that performs effectively in determining the weather condition by leveraging the diverse data set containing the images captured in rain, fog, and snow. We aim to train the model to accurately detect the objects under these challenging scenarios through the rigorous evaluation and the fine-tuning. Our goal is to enhance the system performance and adaptability to the various weather conditions. This project seeks to improve the safety and efficiency in the domains such as autonomous vehicle, surveillance, and environmental monitoring, where accurate and real-time object detection is crucial. Ultimately, we aim to create a versatile object detection system that ensures the consistent and the reliable performance irrespective of weather condition, contributing to enhance the safety and productivity in the diverse applications. These are the basic requirements that are needed to build this project. The software requirements: Python IDE with version of 3.7, Anaconda with version of 3.7 on Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3 and above, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the library. And this step, we import the essential Python libraries such as NumPy, OpenCV, and Flask. These libraries provide the various functions and tools required for the data handling, image processing, deep learning, and the user interaction. And the second one is importing the dataset. The dataset containing of images captured in the different weather conditions, including rain, fog, and snow. These images are used for training and evaluating the yolov5 model for the object detection under the diverse weather scenarios. And the third one is building the model. yolov5 is a state-of-art object detection model known for its efficiency and the real-time performance. And this project, the yolov5 is utilized to build an object detection system capable of detecting the various objects and the images captured under the different weather conditions. And the next step is evaluate the custom yolov5 detector performance. After training the yolov5 model on the weather-specific data set, the model performance is evaluated to assess its performance, accuracy, and effectiveness in detecting the objects under various weather scenarios. Evaluation metrics such as precision, recall, and mean average precision are used to measure the model's performance. And the next step is training the model. During this stage, the yolov5 model is trained on the dataset containing the images in the different weather conditions. The model learns to detect the objects by analyzing and understanding the pattern and features specific to each weather scenario. And the next step is user gives the input. To enable the user interaction, a Flask web application is created, allowing the user to upload the image for the object detection. The Flask framework serves as a user interface for providing the input image. And the next step is the given input is pre-processed for prediction. The input image provided by the user is pre-processed to match the format required for the input to the yolov5 model. Pre-processing involves resizing, normalization, and the conversion of image into the format compatible with the deep learning model. And the next step is trained model is used for prediction. The pre-processed user input image is passed through the trained yolov5 model for the object detection. The model identifies and localizes the object in the image, providing the bounding box, coordinates, and the class label. And the next step is final outcome is displayed. The object detection outcome, including the bounding box, coordinates, and the class labels, is displayed to the user through the class interface. The final result showcases the model's ability to detect the object accurately in the different weather conditions, facilitating the real-time object detection in challenging weather scenarios. Through this comprehensive object detection project using yolov5, we aim to create a versatile and efficient system capable of accurately identifying the object in the diverse weather conditions, contributing to the enhanced safety and the reliability in the various domains such as autonomous vehicle, surveillance system, and environment monitoring. And the execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it. The data folder containing of the data within it, and the models folder containing of the model files which contains the algorithm information, and these can be loaded into the project code during the runtime to utilize the trained model for the various tasks, such as making the prediction on the new data or performing the specific operation. And the static folder containing of folders like of CSS, JavaScript, images, uploads within it. And the template folder containing of the HTML documents. Typically, it includes the about, home, index, notebook, sign in and sign up pages within it. And the test cases folder containing of images that will be used to check the performance of this model. And the app is an py file which likely contain the information related to the front-end logic. It includes the code written in Python that handles the server-side operations such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the notebook is an ipynb file which contains a combination of code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db is a file appeared to be the database file used to store the user information. And for the execution of the project, we build a Flask framework as of frontend. And the overall project code is present in the ipynb file named notebook as a combination of code, graph, and output all in one place. And for the execution, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to change the location of the disk to F because our code folder is present in fdisk. Then write a command cd space and paste this code folder path. By this, it will change the current directory to the code folder path, and then click on the enter button. Here we need to write a command that is python space app.py. By using this command, it will execute the Python script and check the runtime errors or the logical issues within it, and then click on enter button. After running this app.py file, the Flask framework will host the application locally at the default address like this. We need to copy this address and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. And I'm opening this Google Chrome and pasting this address, and then click on the enter button. Here we can see the title and the sign in and sign up buttons within it. And here we need to click on the sign up button, and then here it redirected to the sign up page containing of some necessary details that need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here it will redirect it to the sign in page containing of some details that need to be filled of username and password. I'm entering the username as of admin and also password too. And then click on the login button. Here it will redirect it to the index page where containing of the choose file and the upload button and home, about, notebook and sign out button. By clicking on the about page, we get the details of this information and go and click on the back button. Here, by clicking on the choose file, it will redirect it to the test cases folder that present in this code folder, and we need to select any one of the image from in it. I'm selecting this image and then click on the open button and then click on the upload button. Here it will redirect it as of the car within it and the traffic sign within it. In this way we can detect the object from the images by using the yolov5 with any weather condition. And by clicking on the refresh button, here we can upload another file too by clicking on the choose file, and I'm selecting this one and then click on the open button and then click on the upload button. Here it predicted as of these are cars with their appropriate bounding box with them. In this way we can predict the objects using the yolov5 on different weather conditions. And in conclusion, our project successfully achieved the objective of developing a robust and accurate object detection system using the yolov5 in different weather conditions. By training and fine-tuning the model on the diverse weather data set, we improved its performance, ensuring the reliable object detection and challenging the scenarios like rain, fog, and snow. The system's efficiency and the speed make it applicable to various domains, including the autonomous vehicle, surveillance, and the environmental monitoring. This project outcome contributes to safer and more efficient operation, enabling the real-time object detection regardless of adverse weather conditions. The future implementation of this system holds the promising potential for enhancing the safety and the productivity and the diverse applications.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.